Hi student. Now we can discuss some simple problems related to welded joints. Please listen to the question. A plate 60 mm wide and 10 mm thick is welded to another plate by two transverse fillet weld as shown in figure. Determine the safe load that the joint can carry if the allowable stress for the weld material is 80 megapascal. So in this question the figure is already given in the question, and in that figure, that is this figure on the right side, they are given the dimension of the length of the weld. What is that? That is 60 mm. Then the thickness of the plate is also given, that is 10 mm. So now we can discuss about the transverse fillet weld. We can write that the given data as width of the plate W is equal to 60 mm, thickness H is equal to 10 mm, then the allowable stress sigma is equal to 80 megapascal. And in this question they are asking about what is the safe load of that particular joint can carry. So for a transverse fillet lap weld, this is a lap weld, the equation for sigma is equal to P divided by 280, or that is equal to 0.707 into P divided by H into L. It is already given in the data book, page number 90, equation number 6.2b. Now we can substitute these values. From this value we will get P is equal to 67,892.5 Newton. So they are asking about the value, load value. Now we can discuss about the, on the other hand, the single transverse fillet lap weld subject to tensile load. Again the equation is given, sigma is equal to 1.414 P divided by H into L. That is already given in the data book, page number 90, 6.2a. If we use this equation, we will get the value of P is equal to 33,946.25 Newton. Okay, so it's a simple question. They are asking about the load enough. Then next question. Two plates 100 mm wide by 10 mm thick are joined together by double transverse fillet weld as shown in figure. Find the length of the weld required if the strength of the weld is equal to strength of the plate. Take allowable stresses 90 megapascal. In this question also they are giving the question given by 100 mm width of the plate, thickness of the plate is 10 mm, then 90 is the megapascal. 90 megapascal is the stress. Now they are asking about the length of the weld. So we can substitute all other values here. That is, for a double transverse fillet weld, sigma is equal to 0.707 P divided by H into L. But the strength of the plate is P is equal to sigma into A. What is A? A is the area. That is W into H, cross section area. That is equal to W into H. Here W and H are given. Also sigma is also a given value. So we can substitute the values. That is sigma, W and H here. We will get P, the value of P. That is the load. Now we can substitute all other values except L in the previous equation. Thus we can calculate the value of length. That will be 70.7. Then now we can take the statement, adding 10 mm from starting and stopping of weld run, we have length of each weld will be equal to 70.7 plus 10, that is equal to 80.7, or approximately taken as length of the weld is equal to 81 mm. That is for the strengthness. Now the third question. A plate 60 mm wide and 10 mm thick is welded to another plate by two parallel fillet weld as shown in figure. The above questions are depends on the transverse weld. Now it is parallel fillet weld. Then determine the safe load that the joint can carry if the allowable stress of shear for the weld material is 75 megapascal. So they are given the value of tau. Tau is equal to 75 megapascal. The width is given, that is equal to 60 mm wide. Then thickness is given, h is equal to 10 mm. Also length is given, that is equal to 60 mm. That is in the question. So that is in the figure itself. Now they are asking about the load P. So from the data book, page number 90, equation number 6.2c, we will get tau is equal to 0.707 P divided by h into L. If we substitute all other values here, then we will get the value of P, that is equal to 63,649 Newton. Now we can discuss about fourth question. Again, a mild steel plate of 15 mm thickness is welded to another plate by two parallel welds to carry a load of 50 kN as shown in figure. Determine the length of the weld required. Load is static and second condition, load is dynamic. So in this section the value of P is given, directly given. No need to calculate from equation or no need to calculate using equations. Just take this value 50, that is equal to P is equal to 50 kN, and H is given, that is equal to 15 mm. Now for a static load we can discuss that equation as from page number 90, equation number 6.2c, tau is equal to P divided by 2 into 80, or that is equal to 0.707 P divided by H into L. What is that value? If we substitute all other values here, we will get the value of L. Again, for this strength, to improve the strengthness, we can add 10 mm from the starting and stopping of the weld run. Then that is equal to 30.21 plus 10 or 40.21. We can approximate it to higher value, that is 41 mm. Then next one for a dynamic load. In the first chapter, page number 20, equation number, in the second chapter, page number 20, equation number 2.1c, tau max is equal to tau into Ks. Here, the Ks is taken as 2.7 from the page number 94, table 6.3. Then, if we substitute the value of tau here with Ks, then we will get the value of tau dash. If we substitute the tau dash value in our data in the previous equation or the general equation for tau, then we will get the length is equal to 81.58 mm. Then again adding 10 mm from the starting and stopping of the weld run, we have to find the length of the weld, that is equal to 81.58 plus 10, that is equal to 91.58 mm. Then one more question. For a joint as shown in figure, I can show the figure later. Determine the length of the weld assuming shear stress. Shear stress of 75 megapascal. So this is a figure. In this figure the load is given and the width is given, that is equal to 80 mm. Now the thickness is already shown in the right side of the figure, that is equal to 10 mm. Now we can write the given data. W is equal to 80 mm, H is equal to 10 mm, tau is equal to 75 megapascal, and P they are given, that is equal to 400 into 10 raised to 3 Newton. Now from the page number 90, equation number 6.2c, tau is equal to 0.707 P divided by HL, and if we substitute these values, the known values here or in this equation, we will get the length is equal to 377.06, or we can add the 10 mm for the starting and stopping of the, that is a common logic, adding 10 mm on the length of the weld, then that is equal to, we can approximate to 390 mm. Again in the second case, that is the double parallel fillet lap weld on the both side. Then the equation is slight variation, that is given in the data book, page number 90, equation number 6.2d, that is tau is equal to 0.354 P divided by HL. If we substitute this value, then we will get L is equal to 188.10 mm. Again adding 10 mm, then we will get it is 200 mm. Okay, so total 5 problems we can solve using this method. It's a simple problem for a weld. Okay, thank you.